Hello everyone, myself VTPS. I am studying in 8th semester, Sri Venkateswara College of Engineering. My today topic is typical convolution neural network architecture. Introduction to convolution neural network architecture. Convolutional neural network are the type of deep neural network designed for processing structured grid data and such a image. CNN are widely used in computer vision tasks such as image recognition, object detection, and image segmentation. The architecture of CNN typically consists of convolution layers, polling layers, and fully connected layers. Convolution layers are building blocks of CNN and are responsible for extracting features from input data. Each convolution layer applies a set of filters to the input data to detect patterns and features. The output of convolution layer is called feature map, which represents the presence of different features in the input data. This is the introduction to convolution neural network architecture. Next, convolution layers. Input layers, hidden layers, and output layers. Input layer means it is a layer in which give input to our model. The model of neurons in this layer equal to the total number of features in our data. This is input layer. Next, hidden layer. Hidden layer means the input from the input layer is filled into the hidden layer. There can be many hidden layers depending on our model and data size. Each hidden layer can have different number of neurons, which are generally greater than the number of features. The output from each layer is computed by matrix multiplication of the output of the previous layer with the learnable weight of the layer, and then the additional learnable basis followed by activation function, which makes the network non-linear. Next, output layer. Output layer means the output from the hidden layer is then filled into a logistic function like sigmoid or softmax, which convert the output of each class into the probability score of each class. These are the three types of convolution layers. Next, CNN architecture. CNN architecture means the convolution layers applies filters to the input images to extract features. The polling layer down samples the image to reduce computation, and fully concentrated layer make final prediction. The network learns the optimal features through backpropagation and gradient descent. Next point is polling layer are used to downsample the features map generated by the convolution layer. Next point, common polling operation includes max polling and average polling, which reduce the spatial dimension of the features. Map polling helps to make the network more robust to variation in input data and reduce the computational complexity of the network. This is the CNN architecture. Next, how convolution layers is work. Convolution neural network are convents are neural networks that share their parameters. Imagine you have an image. It can be represented as a combined having its length, width, and height. Now image taking a small pic of this image and running a small neural net called filters or kernel on it with say k outputs and representing the vertically. Now slide that neural network across the whole image. As a result, we will give another image with different widths, heights, and depths. Instead of just R, J, and B channel, now we have more channels, but lesser width and height. And this option is called as convolution. If the patch size is the same as that of the image, it will be a regular neural net. Because of the small patch, we have favor weight. CNN are trained on large dataset using back propagation and gradient descent. The model's performance is evaluated on a separate test set to measure accuracy and generalization. Techniques like data augmentation and transfer learning can enhance the performance of CNN model. Layers to build CNN nets. A complete convolutional neural network architecture is also known as convolution. A convolution is sequence of layers, and every layer transfers one volume to another through differentiable function. Types of layers. Data. Let's take an example by running a conventional image of dimension 32 into 32 into 3. Input layers. It's the layer in which gives the input to our model. In CNN, generally, the input will be an image or sequence of images. This layer holds the raw input of the image with the width 32, height 32, and depth 3. It's convolution layer. This is the layer which is used to extract features from the input datasets. It applied a set of learnable filters known as the kernel to input images. The filters or kernels are smaller matrix, usually 2 cross 2 or 3 cross 3 or 5 cross 5 shape. It slides over the input's image data and compute the dot product between kernel weight and corresponding input image. The output of this layer is referred as features map. Suppose we use total of 12 filters for this layer, we will get output volume of dimension 32 cross 32 cross 12. Next, activation layer. By adding an activation function to the output of the preceding layer, activation layer add non-linearity to the network. It will apply an element-wise activation function to the output of the convolution layer. Some common activation functions are ReLU, max, dan, leaky, ReLU, etc. The volume remains unchanged, hence output volume will have dimension 32 plus 32 plus 12. Next, polling layer. The layer is predictably inserted the convention main functions to the reduce the size of the volume, which makes the composition fast, reduce memory, and also prevents overfitting. Two common type of polling layers, max polling and average polling. If you use max poll with 2 plus 2 filters and stride 2, the resultant volume will be dimension of 16 cross 16 cross 12. This is the layer to build convnets. This is the classification flatter layer, fully connected layer, softmax layer. Next, advantages. Advantages means good at detecting patterns and features in images, videos, and audio signals. Robust to translation, rotation, and scaling invariance. End-to-end training, no need for manual features extraction. Sixth, can handle large amounts of data and advantages. Next, disadvantages. Next point is computationally expensive to train and require lot of memory. Next point is can be prone to overfitting with not no data or proper regularization is used. Next, require large amounts of labeled data. Interpretability limited. It's hard to understand what the network has learned. This is the disadvantages of convolution neural network architecture. Next, applications of convolution neural network architecture. Convolution neural network architecture have numerous applications beyond image recognition, including object detection and facial recognition and medical image analysis. They have been used to autonomous vehicles, surveillance systems, and neural language processing tasks. CNN continues to drive advancement in artificial intelligence and are key technologies in the deep learning landscape. Next conclusion. CNN architecture have evolved over the year from simple model like LetNet 5 and deep network like ResNet. Understanding the components of CNN architecture such as convolution layer, polling layer, and fully connected layer is essential for designing effective networks. While leveraging the power of CNNs, researchers and practitioners continues to push the boundaries of computer vision and artificial intelligence. This is the conclusion. Thank you.